There are different strategies that we can use to solve trig equations, and this one is outlining being able to factor out a linear or a monomial factor first. So here's how this example looks. We've got two trig functions that are being utilized here. Neither of them are squared, and we just as soon not have to square if we don't have to. So if we look at this equation, I can move the negative 2 sine of x over. I can make this 2 sine of x minus the sine of x times the cosine of x. Then if we apply our factorization, I've got the x there, factorization strategy, there's a sine of x that can be factored out of each of those. So I'm going to take the sine of x and factor out your monomial factorization. And it's 2 minus the cosine of x that's remaining, and that equals 0. Now we're down to our zero factor theorem that we've studied. So that means either the sine of x equals 0 or the 2 minus the cosine of x equals 0. In this case, we're looking for the angle whose sine value is 0. There are some places where the sine values or the y values are 0. Y values are 0 on the x-axis. So that means one of our angles is 0, the other one is pi, and since they said we could wrap around one full rotation and include this, we'd also want to include 2 pi. So our solutions coming out of this one are 0, pi, and 2 pi. And that's because we had a domain from 0 to 2 pi with square brackets on each end. Over here, we've got to solve this remaining equation. So we've got 2 equals the cosine of x. I added cosine to both sides, so we're looking for an angle whose cosine value is 2 over 1. Well, this poses a problem because we got a cosine value is always x over r, and the radius can never be shorter than the leg of a right triangle or of our ratio. So this one gives us no real solutions. And if you think about the domain of a cosine value, or the domain of an inverse cosine, they have to fit between a negative 1 and 1. So this one gives us no real solutions, which really gives us only these 3 solutions for question 17.